là bắt xe IDE ấy, nên là
Share.
em nghĩ là phỏng vấn công ty nào thì theo công ty đấy, hoặc là
Ờ,
Google Docs
anh
gì
có
hay
thể
cái gì
anh có thể share cái ID của anh,
cũng
Morgan
được.
Freeman.
Nó Rim con Hoàng hỏi DH nghe nhé, OKX giờ khó đấy.
Ở Google thì chắc là phỏng vấn bằng cái Google Doc đúng không? Nhưng mà anh share cái ID của anh.
Em ra ngoài tí nhé, anh
Ok,
em thoải mái.
ok.
Sâu tốt nhé, phỏng vấn level cao nên cần làm tốt nhé. Ok, em ra ngoài tí.
Lâu anh không có click code nên nhưng mà cứ cứ đợi xem. Ok. Rồi,
Ok,
anh share cái screen của anh rồi đó. Chắc là mình dùng tiếng Anh luôn ha.
dạ nhỉ. Ok
Ok,
cũng được.
ok.
Đẹp nhé. Lên nó có like không nhỉ, hay là hôm nay chỉ ra code thôi?
Ờ, hôm nay chỉ code thôi. Hôm nay là cái mock interview code.
Okay, hello, and my name is Quang, and today I will be your interviewer. So today we have only one question for you and one follow-up. So we have
Ok,
45, 45 minutes. So it's until 12 p.m.
ok.
Okay, so the problem is, so imagine you have a server, an API server, and uh, this API server will receive the request from client, and for each request, you will record the latency
Ừ,
for monitoring purpose. Okay, so the requirement is for you to write a program to um, calculate the average latency of the latest case request. So we only care about the last case request.
Oh, so sorry. Can you repeat the last part? Write the code to calculate
The average
the
latency of the
average latency
latest case request.
of the latest
Yeah, yeah, yeah.
case request. Can you
K.
explain
Uh,
what?
I mean K. It's
Okay. Oh, okay. Excellent.
yeah.
Okay. Okay. Request.
So for example, we have something like um, yeah, you understand the question, right? You
Oh,
can come up with
okay.
simple. Yeah. So
Okay. Yeah. Make
the
sense.
request will come like continuously, and for each
Okay.
new request, you calculate the latest case request average.
Okay. Okay. Understand. Yeah, so let me paraphrase the problem so that I just want to ensure I understand the question fully.
Mm,
So this scenario here is that we have API server which receive the request from client. Each
mm,
client, we have the latency, right? And
yeah.
then the problem here is that we need to calculate the average latency of the latest K request. And as you mentioned, let's say we have the array of the latency. For example, the latency here is maybe in millisecond, right? And then it just keep adding more latency. And this is the dynamic array. And also we have the k as the input. For example, k is the 4. So even if the array here is keep increasing when we have more requests coming, but we want to, let's say, just try to calculate the latest 4 requests. So in this case, 27A7, right?
Yes.
Okay,
So the
okay, understand. So maybe I just think out loud on top of my mind first for the brute force solution, right? And maybe after that we can try to optimize it. Okay, so for the one here, what I'm thinking is that I mean for the brute force, we have the array to store the list of the latency here. And then every time we have the request coming, we add that latency into the array. We can just add to the end of the array or to the beginning. So that is our convention. And with the k here, k4, every time we have a trigger a function to get the average, we just loop from the end of array to forward to the left side of the array with the k elements, we calculate the sum and then let's say divide to k. So that is the average, right?
Yeah.
Some large k latency and then divide for k. So this is the average we have. So for this one, I think the function we trying to write, for example, function is average, calculate average here. Then we have the array, a list of the integer, right? And also the k. So with this approach, every time we call this function, the delay, the complexity, the time complexity first is the OK, right? Because we need to look the last k number to calculate the sum, and then we divide k.
Uh, yeah. So good. But I think the signature of the function should be like the first parameter will be only the value. Okay.
the,
So
the
imagine you have a global list.
Oh, okay, okay. So for the calculate here, it means we want to add the new element.
Yeah, we keep adding it.
Oh, okay, okay. So every time we call this function, we add a new
Value.
latency. Okay,
Yeah, let's see.
latency. Okay, so for example, latency integer, this is also integer, and the value we return is that a Boolean type, sorry, a double type, decimal type.
Yeah, yeah, yeah.
Okay, okay,
So
understand.
so the array is not fixed. It will keep coming. It keep it.
Okay, okay, understand. So in this case, right, if I use a list as a um, global variable to keep track of the value, and this is just we just add the latency to this list. But one thing is that I'm not sure if we have any functionality to use other number, but to save the storage of this data structure, I think we can just use the priority queue, or maybe just use the queue with the
Mm.
limited. So every time we put an element to the queue, we can just remove the other element
Yeah.
that we don't use, so that we always have a k number of the latency in the queue.
Yes.
Yeah, the array list can also do that. We can just remove the elements from the beginning and add a new element to the queue, right?
Yes.
So that is the, I think in terms of the space complexity is only okay in this case. But for the latency here, I think every time we add or we remove, this is we perform at the beginning or end of array. So it's O1. The sum is still the same, okay, here to calculate the average. But I'm thinking, is there any way to optimize the summarize here so that we don't need to do the recalculation every time we add a new latency here? What I'm thinking is that because we keep track of the k element here, so when we add a new element, we have the existing sum, right? Then the sum here is we remove the first element out of the queue. So it just remove the list of 0 here and then add the new latency.
Okay.
So this one, we don't need to go through all the k elements, right? But we still have the new sum. So this is this one, and then we can calculate the average. Some divide for k, right? So this is one way to reduce the time complexity. If we do that, I think the time complexity here is only O1 because we don't need to loop through the array again.
Okay. So
Uh,
good.
yeah.
Yeah,
Mm.
I think this solution will will work. I have a couple of follow-up, but can you implement this first as a warm-up?
Okay, sure,
You can
sure.
we'll go with the follow-up later. Yeah.
Okay, okay, yeah, understand. So for this one, I will Java. I use Java. I'm not sure if we want to run on the code later, but as we discussed, we have a global list for the class. Okay, so it's a list of the integer, right? This is called the latency, new latency, and we have a public function to calculate. This needs to return the value is the double calculate uh, average. The average here is latency. But as we discussed, it's just one single latency.
Yeah.
And then we want to oh, one more thing is that the K is fixed, right?
Yeah, it is fixed. It's
Okay.
already fixed.
Okay, so okay, integer A is fixed and it's returnable. Okay, so the first thing, okay, we also have the global or long is the sum, just 0 here. As I remember, we need to cut this to long. Oh, sorry. Okay, maybe I just try to use the integer sum first, and later on I will try to find a way to use the long integer. So first thing we need to remove uh, the first element out of the list first. So if latency dot size, I don't know, the global field that size greater than or equal to k, then I need to remove latency that remove. Let's see. Oh, a list here. Linked list. Okay, this is a linked list. So that. Oh, sorry. It looks like the ID here is it cannot suggest the function, but
No.
yeah,
It's just latencies, plural. Yeah.
oh, right. Thanks. Okay, so we remove the element at the, oh, okay, we just remove first, right?
Yeah.
And for this one, we can use the for loops to remove until it's less than k, but I think every time we add a new latency, we always remove, so we can just do this. And if yes, we remove this one. So we minus for the latency, get the first element before we remove. And as we discussed, we increase the sum with the new latency. Latency, and then we add that latency to the list here. Okay, so this is we get the new sum, and then we return the average is basically the sum divide to k here. So this is the function that we try to implement this one. Let's say anything else I need to pay attention. Yeah, I think this is basically the code version for the approach we just discussed.
Okay. So good. So good. Okay. So maybe we can go to the follow-up now.
Okay.
So so when you monitor the latency of a server, sometimes you have like outlier, right? Because like sometimes the request take really long time and it will
Yeah.
affect the average, right? So what I want to modify here is like we should ignore like the top X biggest latencies and only care about the average of the rest.
Okay, understand. So you mean that maybe sometimes there's some abnormal latency, and that latency maybe can impact the overall average latency.
Let me give you an example. So for example, we have, I will put into the chats.
Okay. Okay.
Give me a second. So for example, we have 5 latency like this, and k is equal to 5,
Okay.
and x is equal to 2. So that means we need to include 2 biggest latency and only
Okay.
calculate the rest. It will be like, so the 2 biggest will be 20 and 40, right? So the
Okay.
rest will be 20, 10, 10.
10 and 10.
Yeah.
Okay. 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 Understand. So even if let's say for this one, right, I just want to clarify. Uh, we only consider the top k number first, right? And then we remove
Yes.
I mean the latest k latency, and then after that we remove the two latency, which means the final average is k minus x, right? Or we will need to get extra k plus
Uh,
x first, and then we remove the
um,
x there.
k minus x. K minus
Oh,
x.
okay, okay, okay,
So for
understand.
example, so right now, let's say we have one more, like 100. So
Okay,
the latency will be like 10 plus 10 plus 20.
x equal
Um,
to okay.
right?
Yes, so we remove 140. So the number we need to calculate the average. Oh no, no, no. We don't consider 20 here. We only consider
Yes, correct.
the last five. Okay, so 10, 10, and 20. 20.
Mm,
And the sum here is 40. We divide for 3. It's
mm,
something like okay, okay. Okay, understand. So I think for this one, right, because we need to remove the top X number out of the array before we calculate the average. So what I'm thinking is that uh, to faster to get the top X latency, we can just use like the priority queue, right? So with the priority queue, we can maintain um, the number that is sorted in the order. For example, in this case, if we have this list of the value, then we can just put into the list here. So it will sort, and 140 will be in the top of the list. But
mm.
after that, um, we remove these two, and then if we keep the same approach as we discussed below. Okay, I move a little bit below here. So the sum is always the same. The sum is basically the sum of the latest k number, right? But
Yeah.
if we have this top here, we need to solve two problems. Is that the adding new latency, right? Adding new latency to the list, we need to
Okay.
ensure that when we remove one latency of the list, we need to remove out the priority queue here as well. Then this is quite challenging. So need to ensure it's all one again, because for the priority queue here, to find that exactly index, we need to go through the priority queue and then remove it. Okay, okay. Understand, understand. I think there's a technique that we do the lazy removing of the priority queue is that we don't need to remove the number of the queue until we get it out of the queue. Let's say the idea is that, for example, we have five number here, right? And then every time we add any number, for example, 80 to the queue. So the idea here is we need to remove the number 20 out of the queue, right? But we keep this number in the queue until we meet it, and then we don't consider it in the next processing. Okay, so maybe I can just go through step by step to demonstrate what is the algorithm look like. So
Okay.
at the new latency, so the linked list will be this value. Linked list is this 80. Then we remove this one. But at the same time, we need to have a set of the number that we need to remove. But let's say, how about if we have a double number here?
You can have duplicate.
Yeah, duplicate. So what I'm thinking, maybe have a hash map. Then the frequency we need to remove it. For example, in this case, is 20. We need to remove 20 and one out of the list, right? So this is one way that we maintain the priority. Okay, so in this case, the priority will have this value. And the next, so the sum is also the same. The sum here, we have the same value. This one, so at the beginning, this is the value. We minus 20, we increase 80 as the new latency. And then now we need to remove the X executing two, right? So in the priority queue here, we check what is the two highest latency in the queue. So in this case, this is 180. We found that 180 is not in the hash map here. It means we don't need to uh, to ignore these two numbers. So we still consider that these are the two numbers uh, in the window in the subarray that we want to calculate the summary, right? So in this case, we just remove the first two here. Okay, so at this time, the positive Q will look like this, and then the sum will minus to 180, right? And we okay, so this is we remove the top X latency. So the average is the same. We minus divide for K minus X here. So this is the happy case when we don't reach the number that we need to consider it. Okay, let's take one example where we need to consider the 20. For example, if I change this is to 5. Okay, so next time, oh, wait. Yeah, it's still, okay, let's say we have 5 and 0 here. Okay, this is 5 and 0. So let me add one more number to this list, right? So for small list now, I have 10. So I need to remove the next two number. Okay, so
Okay.
the next two number now, this is the priority queue. I add number 10 into this list. So the top two number will be 20 and 20. But this 20 is basically need to remove before, right? So when I pop it out the priority queue, I found that is this in the hash map, and then I need to ignore that one, which means I will consider three number, not only two, because there's one number need to be removed in the previous processing. Does it make sense?
Hold on. So 20, okay, can you repeat this example? Like I a bit confused about the part where you consider three number.
Okay. Okay. So this is after I add the number 10 to the linked list, right? This is the linked list I have. Also, this is the priority queue I have after adding the new number, right?
The
But
number is 10, right? The new number is 10.
yeah. The new number is 10, right? So when I add the new number to 10, I need to remove number 10 out of the list here as well, right?
Mm.
So after remove, I remove this 10. So this number 10 is also needs to be removed of the priority queue. So the hash map now is like this, 10 and 1. Anyway, okay, 10 and 1. Okay,
Okay.
so now I need to do the summarize. Summarize is basically the same. I need to have the some. I minus for the number 10 that I just removed, and I add the new number 10 to the array. But the problem here is how do I calculate remove the x here? So the x here, I need to remove the top two number of the queue. So in this case, it's 20 and 10. But when I actually get the top two, it will return this 20 and 10, 20, right? So the first time I get the number 20, I check there's a hash map saying that in the past, I need to remove 120 out of the queue. So I will ignore this one. So which means I will ignore one and then I remove the hash map. I remove this one as well. This is for the first pop out of the priority queue. The next pop, I get 20 and there's no 20 in the memory of the pre-processing. So I minus to 20. Another pop-up is that I get number 10. So for this number 10, in the past, it's saying that we need to remove another number 10 out of the queue here. So I remove this out of the hash map, also remove it out of the priority queue. So I
Mm.
still need to pop another 10 out of the queue here. So it's another 10 here. So there's two 10 number. Okay, but let's say after I get out the 10, I need to still keep it, right? Last time I accidentally removed 120. But basically the idea is that the 20, the queue in the priority is basically the same with the linked list. After we remove the we do the lazy removal, the hash map will be empty, and then we keep the consistent between the linked list and the priority queue.
Okay.
This
Uh,
is a bit maybe confused if we just do the text kit. I'm not sure if we can use the maybe a diagram to demonstrate this. What do you think? Yeah.
uh, yeah, I think it might work, but it's a bit complex, right? Because you need to
Yeah.
maintain like three data structure here.
Correct. So the downside of this approach is that we need the extra priority queue to maintain uh, the list of the sorted latency, right? And at the same time, we do the lazy removal, which means we need to have another hash map. So the space complexity that we need to extra okay here to store the space complexity.
Okay.
Yeah.
How about the runtime?
The runtime in this case, it still maintain the same because we try to do the lazy removal. So we don't need to look through the whole priority queue here to remove the element every time we add the new uh, element to the linked list. We do the lazy removal. So the the full search of the priority queue is unnecessary anymore. So it's still a one, yeah. But it's a little bit complex in terms of the
Wait. When you get biggest number from the parity queue. It
Yeah.
is a 1, right? But when you insert it, it's still log n, right?
Oh, correct. Yes, you're right. You're right. Yeah, I didn't consider the time complexity when we add the new element to the priority queue here. Yeah,
Oh,
it's
uh,
the log n here.
yeah, I think this might work, but it will have a complex implementation.
Correct.
We still have like
10.
20 minutes, so maybe we can think about another solution, a simpler solution for
Mm,
like
mm.
5 or 10 minutes. If after that we still cannot make it, we can go back to this and implement it. Okay.
Okay,
Uh,
makes sense.
so maybe you can think about some data structure that can maintain the order, and because we only care about two number here, like one number we
Mm,
add and one number we remove.
mm.
So think about like, is there any data structure that can maintain the order and can quickly insert and remove?
Okay, makes sense. Yeah, thanks for the hints. I think there is the okay, understand. But that data maybe the new data structure, right? But that new data structure needs to solve two problems. Is that the first thing is that keep the order of the element
Mm.
same with the array, right? Because we want to remove the element that is um, first insert into the array to keep the size of the array is k, right? But the second thing is that it can get the two biggest the x biggest latency quick. Okay, so this is the requirement that for the data structure we need to consider, right? Need
Mm.
to keep the order of the element with the same array so that we can remove that element out of the window, the window size, and yeah, to maintain the k size of the array. But at the
Um,
same time,
I think for the first part you don't need it, right? Because you can use a queue to do that,
a
right?
queue. Okay, so it's still the same linked list, right?
Yeah,
Linked list. Yeah.
the link is
Okay, but if we I mean if we don't consider these two together in one data structure, and then it's pretty much the same with the solution that we have here. One is to use the linked list, another one is to get the x biggest latency quick.
I think there's another requirement. Number 3 is to quickly remove, right? To
Mm.
quickly remove an element, because we need to remove the uh, stale latency, right?
Correct. Yeah. So, this one, maybe, yeah, maybe my expression is not that clear, but the purpose of this one is that we can quickly remove the elements of the first
Oh,
element of the queue. Yeah,
okay.
yeah. Maybe my expression is not the same with you, but the purpose is the same. This
Okay.
data structure can have to remove the first element uh, of the array quickly. Yeah. So this one, I remember there's a tree map, tree
Uh-huh.
tree map data structure. But let me remember what is a tree map here. I think tree map is can get the X biggest latency quick, but I don't remember if it can remove the element by the index. Yeah, I think basically the basic idea of this out of this tree map is the combination between the linked list and priority here. It's abstract the way that um we store the element in order, but at the
Uh-huh.
same time we can get the sorted elements out of the list quickly. Yeah, I think this is the tree map here. Yeah. But I'm not sure this is the exact one that it for this requirement. I'm not sure if I can use Google to find the functionality of this data structure.
Gmap, let's see. Gmap. I
In
don't think.
Java.
Yeah, Java, right? You can use this, but I think Gmap it doesn't support application, isn't it?
Oh, but the map maybe let me
Yeah, Gmap. Yeah, I think. Let me see. Gmap.
map.
Yeah. Yeah, it can, right? Because you can use the key as a value and the
Map is the a frequency of that number.
frequency. Yes.
Uh, Actually, I just asked ChatGPT without your
Yeah, yeah.
permission,
The
but
key, the key is unique, but you can use the frequency, the value to start the frequency.
right. Yeah. But it can have duplicated value. So basically, tree map is like a key value is maintain a key value pair.
Yes.
So the key is the value is the latency, and the value is can be the frequency that latency happens.
Okay. So
Yeah.
back to the question. So how can we get the top K, top
Mm.
X, right?
Yes, but if it, yeah, I understand your question here. If it maintain the frequency, how do we get the top compute? Wait a second. Uh, then it so the um let me try to remember.
Yes, tree map it's already sorted. The key is already sorted.
Yes. So let's say yeah, I think for the key, it can do the sorting on the key, but not in the value. So, oh,
We
basically,
don't need we don't need the value, right? But the value is just the frequency.
yes, the value is just the frequency. Uh, oh, sure, why I cannot click into this anymore. Okay, here. So the tree map maintain a list of the key value pair, right? So key is the latency, and then value is the frequency that the latency happen. So in this one, the first thing is that add a new latency, then we can check to see if it exists in this. But how do we get the size if we store it like a key value here? Maybe we need to have another external variable. It's the sum frequency, right? And if
No,
this sum
I think you can also use the queue, like
the
the queue and the tree map.
uh,
So the queue to maintain the window, right?
correct. Yeah. So it's like queue like
Or the link
let me
list.
see. Yes. So if the um queue size greater than k, and then uh we need to remove it out of the queue. Right? You remove 0 here, and then queue that add that new latency. So now we need to handle the data in the tree map. So if it's greater than k, we need to remove. So let's say this is a map here. So before we remove this one, we need to check in the tree map to see if the key is it. So this, let's say because this first, if it map contain this first here, then we check map and then something like reduce this one. Reduce is like get first and then -1. So it's we reduce the frequency. And if this one equals 0, we remove it out of the queue directly, the map directly.
Okay.
Yeah. So this is one way that we maintain the consistent between the linked list and the tree map. The second step is that we pop. Okay, but we need to add as well some map. We also do the same. If the map contain the new latency here, then we increase the frequency. Increase the frequency, right?
Okay.
And if not, we just add frequency is 1, right? And the next step is to calculate the average. So yeah, due to the data structure of the tree map here, we can get the sum. The sum is the same with what we did before, but it needs to minus the x2 biggest. So because the map it can so this is pseudocode. We need to get the x biggest number here, and then the average here is basically divide for
Okay.
a minus x. Okay, yeah.
Okay. So what is the runtime of the number
Okay.
2?
So I think for the runtime for the queue itself, the runtime is 01, right? But we need to consider the runtime of the map here. For the map, this one check to see if it contain or not. So it's 01. But for the time complexity of get the x2 here, I think every time we get one number out of the tree map is the log k here because k is the size of the map. And yeah, we time complexity is must o x multiplied to log k.
Okay. Let me see. Get x. Get x. Get x. Log.
One way of doing this is that for we keep remove the top element of the map until we get enough x number. So every time we remove one element, we have the log k. So it's the multiply x. And after that, we need to push the number back to the tree map so that later on we can still get the value. But by doing that, it will change the order of the element.
I think you don't need to
Yeah, yeah.
don't need
It's
to
like,
remove, right? We just iterate
yeah. For
and
each,
accumulate until we have enough x, right?
yeah. So
Okay.
for
Um,
yeah,
so I think this one will be O X, right? Because we just iterate through the map one by one.
yeah. So this for the first is OX, right? But I'm not sure every time we uh yeah, I'm not sure every time we get an element out of the map, is that O1 or O or log K. So this is one thing I'm thinking. Mm-hmm.
No, no, I mean you do not for the from 0 to 8. You for like um because the key is shorted, right?
Yes, yes,
So
yes.
you go from key by key,
Oh, right, 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 right,
like
right.
entry to entry.
Yes, yes, yes. Okay, so if the key is sorted right, so I need to consider when I add the new latency, because for the add here, every time I need to put that here, this one.
Mhm.
I put the new latencies to the queue. I'm not sure this one will
Yes,
increase.
it's locked. It will be locked.
Okay, 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 okay.
Yeah, it will lock. Yeah.
Okay, yeah. Thanks for the reminding. So I think the latency here is log k at the time of the booting. So yeah, yes. The overall time complexity is log k. Log k is here when we add new element to the tree map.
Yes, correct.
Yeah.
And
For space complexity, I think time complexity, then space complexity. I think we use the extra, right? So it's also okay for the map, for the queue ones.
one thing. So when you add a new element, it's all log k. But when you calculate the average, it sees OX in worst case, right?
Oh, ask in
In the
was
calculate the average.
uh correct, correct.
But you need to like in worst case, it will be the frequency will be 1, right? So you will
Mhm.
need to um
Yeah. So when we do the calculate the sum, we need to, yeah, because every time we have the iteration to get the x biggest number. So yeah, calculate some x latency.
okay.
Yeah. So time
Um
complexity is the mass of one of these two.
yeah, okay. Um Actually we can still optimize this to make it always log k when you
Mhm.
calculate the sum. Um do you want to follow that part or you want to implement this? I don't think we
Uh,
have enough time, but let how about this? I give you a hint. You don't need to implement this. Just
okay.
tell me what you think about it.
Okay. Yeah.
So the target is to further optimize the calculated sum. Right. Right now it's OX. We want
Mm.
it to be log K.
Mm-hmm. Yeah.
Okay. So right now you have one tree map, right?
Mm-hmm.
How about think about like what if you can maintain two tree map, one for the top X and one for the remaining. So you just manipulate two tree map whenever you add a new element, right?
Mm-hmm. Okay. Okay. Understand. And then to remove the complexity of the OX here, we just maintain the sum of X of the tree map, right?
Mm,
The sum of the tree map that contains the X biggest element.
mm.
Okay. Okay. Yeah, yeah. I think I get that point.
Uh, sorry. But what I mean is like you have another tree map, like you have
Yeah,
two
yeah.
tree,
Yes, yes, yes.
yeah,
Uh,
and the
I
sum of
think,
the
yeah,
rest, yeah.
yeah. So if we have two tree map here, so this another tree map to contain the X biggest
Okay, yes.
latency. Latency. Okay. So the idea, I think it at the step of the add new latency here. Um, so when we add the new latency, what we can do is that for the queue, it's still the same. We remove the first and add to the end. But for the map here, Um, First, because we maintain two latency, then we need to compare that new latency
Mm.
with the exhibit latency here. If this one is greater than the smallest
Right, right.
uh,
You
the
under
smallest element in this one, then we need to reallocate the smallest to the second
yes.
tree map, add this
Yes.
new latency to this one.
Mm.
And this way we, yeah, the main idea is to balance uh
Mm.
just try to partition the explicit is in this tree map and the rest is in the second one.
Mm.
And then we have another sum, which is to maintain the summary of the X bigits tree map here. So that is always log K because we don't need to recalculate this tree map again. Yeah.
Okay. Yes. You are on the right track. How about the when you remove? So here you add, right? But how about the remove part? You
Yeah,
need to
yeah.
it's still.
Correct, right. So when I remove the element out of the tree map, uh, I need to check. Yeah, I need to check two tree map here to see if the element that I remove exists in these two tree maps. If it exists, then I so first, if it is in the biggest latency here,
Mm.
then I just remove it and then I pick the top element in the second tree map. I
Mm.
reallocate to it, right? If
Yes.
it exists in the second tree map, then I just need to remove it out of the tree map because it's in the second partition and all the element in the second partition less than the one in the X biggest here. So I don't need to uh, reallocate the element.
Okay.
Yeah.
So
So
the runtime will be
so
long.
let's say because I need to check into two tree map. So the checking is it or not is a one. And then when I remove one element, basically it's the same with the previous one. When I remove, I need to check if it's content or not. If it's content, then I minus one of the frequency. And after
Mm.
minus one is zero, then I just completely remove that element out of the map.
Okay.
Okay. Um, I'm thinking about the order of the element after I remove out the tree map. That the order of the elements is the same between the two T map. Because I have two T map to main. Oh, right. Because the order is maintained in the linked list here. So yeah, I just keep I
Mm.
just keep tracking the elements in the link. Okay, yeah, it's still satisfied because
Okay.
the order. Okay, okay, understand. Yeah, yeah, I think that is basically the idea, and thanks for the hint.
Yeah.
Uh, do you think I need to implement the
Time's
solution,
up.
the approach?
No need, no need. Time's up. Time's up.
Okay,
We're
cool.
running out time, so uh, okay.
Uh,
Bài
the,
này thì
okay.
bài này nếu mà N5 ấy, senior ấy, hoặc là
Uh,
senior ở Google hoặc là staff ở các công ty khác thì em expect là sẽ uh, candidate sẽ tự
từ
implement tự nghĩ ra solution
ừ,
của cái optimal ấy
ừ,
và implement được. Đúng không?
ờ, ừ, ừ,
Còn bài của anh thì em nghĩ là sẽ bị down level xuống L
ờ,
L4 hoặc L5 ở các công ty khác. Anh đã áp staff đúng không? Thì có thể là sẽ bị
ờ,
down level xuống senior.
ờ. Anh cũng nghĩ vậy.
Ừ.
Um,
Trong cái guideline thì nó nếu nếu mà nghĩ được đến cái đoạn này thì là nó là cỡ khoảng L4. là 4 là có
ờ
Meet ở Google và khoảng Senior ở bên ngoài. Ờ,
ờ
thì em nghĩ là mình anh còn bao lâu nữa sẽ phỏng vấn?
ờ, anh còn 1 tuần nữa. anh
Ờ, chắc
anh hẹn mình ngày 2 tuần chứ,
ok.
2 tuần
em
nữa.
em nghĩ là check lại, mình còn thời gian mình check lại mấy cái cấu trúc dữ liệu phổ biến
ờ
trong Java ấy.
ờ
Gmap, reset, hashmap, gì đấy không nhớ lắm, nói chung là có mấy cái cấu trúc dữ liệu phổ biến.
ừ, ừ.
Ờ, còn cái dạng này thì cái đoạn mà em gợi ý là có dùng hai cái Gmap thì em nghĩ là anh sẽ liên tưởng đến một bài khác đúng không, một cái bài dùng hai queue đúng không, hai cái heap đúng không, bài này cũng
ờ
tương tự kiểu vậy nhưng mà nó sẽ thay vì dùng heap mình sẽ dùng hai cái Gmap.
ờ ờ Thật ra em thấy cái tree map này kiểu nó là một cái combination giữa hai cái này này, mà khi mình implement theo cái solution này thì
Ừ.
nó phức tạp. Thì nếu mình có thể sử dụng một cái data structure có sẵn thì cái implementation nó kiểu nó đơn giản hơn.
Cái này mà dùng dùng sim cộng ấy là nó sẽ có cái multi-set ấy. Multi-set thì nó dễ hơn,
ừ,
còn multi-set trong Java không có nên là phải dùng Gmap.
ờ,
À, thường những cái bài mà hát ấy, những bài hát thường nó sẽ là kết hợp giữa nhiều cấu trúc dữ liệu.
ờ, ờ.
Yeah.
Thì ví dụ như là cái lúc mà anh làm cái ý tưởng solution của anh á,
Ừ.
anh kết hợp những cái cấu trúc dữ liệu này, kiểu có thể là kiểu implement phức tạp đúng không, nhưng mà kiểu cái
Nó
complexity cuối cùng nó bằng dưới một cái solution mà chỉ dùng duy nhất một cái data structure, thì cái đó nó vẫn chưa optimal đúng không, mình vẫn
à,
phải.
không, em nghĩ là vẫn được ấy, vẫn
Ừ.
cái cách mà anh dùng ấy, cái cách của anh ấy, cái cách
ờ
mà dùng priority queue với hashmap ấy
ờ
là vẫn ok ấy, nhưng mà em muốn challenge thêm nên là em đẩy đẩy sang cách này thôi, còn
ờ ờ
còn cách đấy em nghĩ vẫn được ấy. Đến đoạn đấy mà em cho anh cài thì chắc chắc cũng được, nhưng mà em nghĩ là cái đoạn này cài sẽ khó, cài sẽ hơi
ờ.
lòng.
Ừ. cái lúc mà implement thì nó kiểu nó hơi rối ở cái đoạn kiểu mình check cái frequency này nọ, khi mà mình dùng cái tree map này thì kiểu nó abstract cho mình rồi, kiểu mình chỉ cần dùng cái functionality của nó thôi. Ok, ok. Rồi.
Và tụi OKX này nó có bắt chạy không?
Cái này anh cũng không rõ vì lần đầu tiên anh phỏng vấn OKX, nhưng mà nếu mà code Java với lại là OKX nó dùng Java thì anh nghĩ nó có thể là bắt mình chạy được, có thể là bắt mình chạy.
Ừ.
Nếu mà bắt mình chạy thì chắc anh không đủ thời gian đúng không?
Anh hỏi thằng Lâm xem,
Ừ,
nó
để
có nó quen mấy người đã từng phỏng vấn OKX chứ.
ok.
Trong team EngineerPro có một bạn, có một anh gì nhỉ, có một anh, nói chung có một anh làm OKX thì anh sẽ biết là có cần chạy không.
Ok, Turing Studio. Ok, rồi. Để anh làm cái này. Nếu mà yêu cầu chạy thì chắc là anh phải kêu cẩn thận hơn cái lúc code đó. Nếu mà code không nhớ syntax hay là nhớ tào lao thì execute nó lỗi lên lỗi xuống thì cũng tốn thời gian.
Ờ.
Ờ,
Còn như kiểu Google thì dễ, kiểu code Google Docs thì nó không bắt chạy, thì nó có thể
ờ,
du di kiểu mình bịa ra một cái hàm gì đấy cũng được.
ờ, ờ,
Ừ. Có một cái to do nữa anh có thể consider đó là xem lại mấy cái cấu trúc dữ liệu
rồi.
phổ biến. Mấy cái là lạ priority queue rồi Gmap, hashmap, reset, hashset. uh,
Cái preset em preset. Ừ. Set. Chê. Ừ. Ok. Um, cái, ừ. Kiểu cái này em thấy theo theo em là kiểu cái level nó phụ thuộc vào mình sao nè, mình có thể tự optimize solution mình đúng không, mà còn không cần hint nếu mà tự
ờ,
xin
có
start
thể
from.
có cần hint nhưng mà như
ờ
ở- em hint ở trong bài này là em hint hơi
ờ
nhiều, em hint hơi
ờ
nhiều.
ờ.
À,
Nhưng
thường expectation là sẽ phải nghĩ được optimize.
ừ, ừ,
cần ít hint, và kiểu anh sẽ là người lead, đúng không?
ừ,
Anh sẽ là người lead cái conversation, em
ok.
chỉ tập trọt thêm mấy câu thôi.
Ờ,
Còn
còn
cái gì nữa nhỉ? Còn em nghĩ là cái ưu điểm của anh trong cái bài này ấy, đó là anh kiểu talk out loud được, anh nói được cái luồng suy nghĩ của mình được. Cái đấy là một cái
ờ,
ok, tức là em có thể collect được nhiều cái signal từ từ cái lúc mà anh, khi mà anh nói ra ấy, thì em nghĩ là nó khá là ok, thì mình sẽ cứ tiếp tục làm như vậy thôi.
ừ, ừ, thanks em. Ờ, cái này em tin nếu hồi 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 xưa ở Google thì hiện tại level ở Google em là mà gì em
Em là
Google
bốn,
em
em là bốn.
là 4. Em thấy cái quy trình không mới anh cảm nhận sau cái feedback của em luôn, em thấy quy trình phỏng vấn coding của Google nó cũng cái phân chia level rõ ràng đúng không? Cùng một bài toán nhưng mà nếu mà senior hoặc là staff thì còn
Ờ,
phải chủ động optimize, chủ động think out loud, cần ít hint trước giờ.
và thường
ờ
L năm nó sẽ expect là giải được hết follow up.
ờ
Còn nếu cái bài này, nếu mà L3 ấy, thì chỉ cần giải được bài đầu tiên thôi.
ờ ờ yeah,
Còn
yeah.
L4 là giải được cái bài này và cái follow up, và
Em tôi hint.
được cái mà OX, cái mà chữ optimize hẳn ấy.
ờ ờ cái này là kiểu anh kiểu không 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 chủ động được này, anh không nghĩ tới được cái này có thể remove được cái OS luôn.
Ừ.
ờ Còn hai cấu trúc dữ liệu.
L5 là phải đi đến tận cùng luôn.
Ừ.
Đó. Thường nó sẽ phân chia theo kiểu follow up, giải được follow up hay không.
ờ Trước giờ thường thường anh sao ta? Cái lúc mà phỏng vấn anh rất rất hay chủ quan, kiểu anh code rồi anh cũng cố gắng optimize, nhưng mà khi mà anh cảm giác hơi bí bí là anh kiểu can you give me the hint, sau đó thì anh cứ giải thôi. Nhưng mà cái này là một trong những cái tiêu chí để down level đúng không? Hồi xưa anh phỏng vấn ở Amazon cũng down level một lần.
Rồi.
Ờ, Uber thì anh bị fail vòng code luôn, thì
À,
không ngờ là cái vòng code kia nó cũng có cái tiêu chí rõ ràng như vậy. Ở TikTok anh cũng đi phỏng vấn, nhưng mà kiểu anh phỏng vấn anh cảm giác nếu mà pass được vòng code thì cho qua cho tất cả các level thôi. Bởi vì thường thường level ở TikTok thì nó biệt khi mà mình vào system design là mấy cái
ừ,
behavior. Ờ,
ok.
em có feedback giùm giúp anh cái điểm đó anh còn improve nữa mà.
À,
Feedback ở Google chắc là chất lượng nhất trong mấy cái công ty anh nghĩ.
ờ, để xem nào. Ngoài mấy cái feedback vừa rồi thì em xem có cái gì nữa không.
Nice. Cảm giác cái complexity, cái lúc mà phân tích cái complexity kiểu anh
Đúng rồi,
cũng không cẩn thận
complexity.
lắm đúng không?
Đúng rồi, đúng rồi.
ờ
À,
em nhắc cái vụ OS này thì anh mới nhớ cái này, chứ còn thường anh ignore mất cái này.
đúng rồi anh, tức
Ừ.
là ở cái to do item đầu thứ hai ấy, lúc mà anh xem lại review thì xem lại cái runtime của mỗi cái function nào, và lúc mà tính runtime thì tính cẩn thận.
ờ ừ. Let's see. Okay.
Còn bài này thường nó sẽ có cái màn là dry run một cái test case, nhưng mà hôm nay mình không có đủ thời gian để dry run một cái. Ừ. Thì nếu mà có thời gian thì có thể anh sẽ cần dry run, bởi vì ở cái level senior thì nó đánh giá cả cái đoạn test ấy.
ờ
Nhưng mà cái đấy kiểu nếu đủ thời gian thôi, còn không thì Không thì mình vẫn focus vào giải trước đúng không?
Ờ, kiểu kiểu cái này là optional hả đúng không?
Yes, optional nếu có thời gian.
Optional. Ừ.
Ờ, yeah.
Ok, yeah. Optional. Think out loud. Ừ. 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 Out loud.
Yep.
Ừ. Ừ. Ờ, anh
Có
cũng
một có
nói
một
là
cái,
ok.
ví dụ như là lúc em mới vào phỏng vấn đúng không, em đã
Ờ.
nói với anh là hôm nay chúng ta sẽ có một bài và một follow up ấy.
Ờ.
Bình thường không phải thằng nào nó cũng nói như vậy,
Ờ.
thì mình có thể hôm
Tự
nay thì
hỏi
anh nói
luôn.
đúng không,
Ờ.
thì anh có thể hỏi nó xem là để mình adjust cái tốc độ của mình ấy.
Ờ. Đúng 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 đúng.
Ờ, yeah. Hỏi nó là hỏi bao nhiêu bài, có follow up hay không, bởi vì có thể là cái bài đầu tiên nó hỏi chỉ là warm up thôi,
Ờ.
mà nếu mà mình focus quá nhiều vào cái bài warm up mình lại không đủ cái thời gian để focus vào cái phần chính đến phần sau nhá.
Ờ.
Ví dụ như bài hôm nay là cái bài warm up là bài dễ thôi, bài L3 thôi, thì nếu mà anh mà kiểu spend too much time thì nó bất lợi cho mình.
Ờ. Đúng đúng đúng. Ờ. Ờ. Ok. Cái này chắc để anh hỏi
Ừ,
anh anh
chủ động
anh
hỏi ra.
anh hỏi cô Lâm trước luôn để anh biết. Anh chuẩn bị thường thường nếu mà OKX có một cái pattern thì có thể là nó sẽ hỏi hai hay ba câu gì đó để anh chuẩn bị trước, để nhiều lúc mình mới vào mình cứ chủ quan mình rà rà hết thời gian mất.
Ừ.
Ok ok. Ừ. Rồi anh nghĩ cái này chắc chắc như đó được. Ờ, nếu mà trong quá trình liền anh có thắc mắc gì chắc anh Bing anh hỏi Messenger em được ha, hình như anh có kết
Được,
bạn Facebook với em.
được. Ok,
Ờ,
ok, thế thôi nhỉ.
rồi ok.
Good luck anh nhé.
Ok rồi cảm ơn em nha, khi
Dạ,
nào
dạ.
có thời gian thì anh em mình nói chuyện sau.
Ok, cảm ơn anh.
Rồi, rồi bye bye.
Bye bye.